All right. So let's talk about what we did last time. Actually, the last 2 days, I think. We at some point had so much fun with that handout that I made with the giant triangle with the multiple triangles in it. Do you guys remember that? And we developed. That's where we got this from. These businesses. Yeah, blah 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 blah. And then we got, well, what if A and B are both the same thing? Does anyone remember what sine of twice theta is? This is the nice one. Does anyone remember? Sine A plus B is sine A cosine B plus sine B cosine A. So if they're both theta, this would be sine theta cosine theta plus sine theta cosine theta, which is 2 sine theta cosine thetas. Okay, and the crowd goes yawn. What was different about cosine 2 theta? We treat it, we get it the same way. So these are both theta, that'd be cosine, which is cosine squared theta minus sine squared theta. So that's the first level of what this is. But, like somebody said earlier, cosine squared is 1 minus sine squared. So if I replace cosine squared with 1 minus sine squared, I get 1 minus sine squared minus sine squared, I get 1 minus 2 sine squared. So this is the one I remember. And then I could make this if I needed to. And I can make it this. If I replace sine squared with 1 minus cosine squared, I get this. So those are all three equivalent. If I put 35 degrees here, I get the same answers here, I get the same answers here. They're all the same. They equal each other. Quotations. Whatever angle I plug in is going to work. Now this is the double angle formula. And I have to tell you this, the half angle formula is dumb. It just is. I don't know if I said this last time. If I start here, we did this last time, so that's why I'm going a little bit fast. If I just solve for cosine squared theta, if I add 1 and divide by 2, I get there. Now the only difference between what I just wrote and what we did last time is I replaced this with theta over 2, which makes that theta, and I took a square root. But a lot of times we could actually write it like this. It's just one step or like 2 steps away from this. And what's funny about this way to write it, if I have an angle that sucks, like 22.5 degrees, well, twice that's 45. And this actually makes a little more sense if I write it like this, without a theta over 2. I don't know if you guys are with me or not. So this is perfectly fine. And then I leave the square rooting to do when I do an actual problem, and then I can pick if it's plus or minus. Now, the 2 things I got to do to make it look more like what you see in a textbook, what you see on that sheet I gave you, is I got to, number 1, take a square root. And that's where the plus or minus comes in. And number 2, I got to change this with half theta, which makes this one theta. So all that really has to be true is whatever this angle is, this is half of it. Is that true here? Whatever this angle is, that's half of it. There's that angle, is that half of it? What angle is this? And what's half of 2 theta? So, let's try this again. Is this angle half of this angle? Yes. Okay. That's why this is the same as this is the same as this. I don't know if you guys are really truly with me. I personally never memorized this one. I just started here. Actually, to be honest, I started here and just solved for the one I wanted. So let me show you an example. Let's say I want to know. Shut up, Jeff. Let's say I want to know the cosine of 105 degrees using a half angle type thing. Yes? Well, if I start with this, this away. You don't need that shit. If I start with this, and I put 105 here, well, Jeff, you could do it. If I put 105 here, then this is going to be cosine of twice 105. Now this is an angle I know. What's the reference angle for this guy? 30. But you see, you have to have this memorized already, don't you? So here, I know last time I created the half angle formula because you're going to have teachers in the future that are going to say, you got to know the half angle formula. What's the half angle formula? But I want to show you, this is what I did. I'm like, I got enough shit in my head. What are you talking about? I don't want to shove something else in there. I don't need to. If I just know this already, and I need 105 degrees, I'm going to put that here because twice it is an angle I know. Now, can I solve for cosine of 105? How do I solve for cosine of 105? Add 1. Right? Divide by 2. Is that cool? And then take a square root. Now, when I take a square root, is the cosine of 105, should it be negative or positive? I don't give a shit that it's an angle we don't know. We know where it is. What quadrant is it in? Is it in? Second. It's a little past 90. What's cosine in the second quadrant? So when we take a square root, we pick the negative. Yes. Now listen, do you understand you don't have to do any of this shit I just did? You don't have to do any of the shit I just did. Let me show you why. This is what I get this way. You're not done, are you? Because you have to actually figure out what 210, cosine of 210 is, and blah, 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 yes? But if I just apply the half angle formula directly, I want to know what cosine of 105 is. So that makes theta what? What do I cut in half to get 105? 210. So over here I'm going to put 210, and I know it's in the second quadrant. Didn't we just get the same stupid thing? Yeah. We sure did, Jeff. All right, maybe you guys understand. I'm trying to show you the agency you have within the shit you're forced to memorize. You have agency. You can either just memorize this formula, yes? What's the only difference with the sign? Half angle. Everything's the same except? What does cosine do to poor sine? It gives him the one that's got the... Does anyone remember? There's only one difference between the half angle formula for cosine and the half angle formula for sine. It'll be 1 minus cosine theta. Yeah. Okay. So if you don't like what I did with this page down here, you can just memorize the half angle formula. That's fine. Nothing wrong with that. Teachers are going to expect you to be able to use it. They should be flexible if you don't have it memorized, but you can construct it when you need to. Okay. You stop for a minute. I mean, I'll be lots of tears. If a student said, I don't have it memorized, but I know how to get it if I need it, a little tear would come out. Of joy, not my weeping corner kind of tears, but a little tear of joy. If your teacher doesn't do that for you, then well, you never know. People are different. All right. That's basically what we did last time. Was we talked about half angle formula, double angle. I think we did a few examples of both. Is everybody up to date now? All of this. I did. Yes, thank God. Oh, I'm recording this so I don't get the glare. Yeah. I appreciate it though, because my other class I completely missed one day last week. I just forgot to turn the damn thing on. I was like, shit. Okay, so what we're about to get into, I am actually not going to say much. And you're like, I'll believe it when I see it. Shut up. I'm going to let you guys I want to let you guys look this over for a bit first, and I'm going to pair you up with other people's. So this is my attempt to break down the steps you need to understand to be able to solve trig equations. So kind of glance over the whole thing, get a feel for what I'm asking in each section, and then I'm going to pair you guys up. Before I pass away, let me catch up to you. All right. I'm noticing a few edits I want to make to this, but the thing I'm trying to make sure you understand is there's two components to solving trig equations. There's what angle fundamentally makes the number show up. So I mean, these should have went pretty quickly, yes? How do I make sine 1/2? Pi over 6, because sine doesn't like the x-axis, so it'll be smaller when it's close to the x-axis. Cosine 1/2 would be the other way around. How do I make tangent 1? That kicks ass. That would be pi over 4. How do I make cosine big? Pi over 6. When sine's small, cosine's big. And then how do I make tangent? Now here's the trick. I'm pretty sure I told you guys this. For the longest time, I didn't have a way to remember tangent. I just built it. But I realized tangent is sine over cosine. So when sine is big, tangent's big. When sine is small, tangent's small. And the possible values of tangent are rad 3 over 3, 1, rad 3. And then you have 0 and infinity. Yes, that's the extremes. So this is small. Tangent is small when sine is small. What angle makes sine small? 5 over 6. Okay. The second part that you need to be able to do by itself to solve a trig equation is what quadrant should I be in certain situations. So if I know the sign is negative, what quadrants should I be in? Sine likes y. So if sine is negative, y must be negative. Y is negative in which quadrants? 3 and 4. Cosine's negative in 2 and 3. It's positive in 1 and 4. Negative in 2 and 3. Tangent's negative when cosine and sine have different signs. And when does that happen? 2 and 4. So let's put all this together. And here's one correction I need to make when I redo this worksheet. What angle in quadrant 1 makes cosine 1/2? Pi over 3. We already knew that from here, yes? So that makes the number work. Pi over 3 makes the number work. Now what quadrants make the sign work, the SIGN? Make it negative. Where's cosine negative? 2 and 3. So I need the angle to be pi over 3 or related to pi over 3, a reference angle of pi over 3, and I need to be in the second and third quadrant. So I can literally draw myself. Here I am, my reference angle is pi over 3 in both cases. What's the actual angle in both cases? So what angle would stop here? How far short of a full pi am I here? Let me see. This is really, we zoom in on this tiny little picture. How far short of a full pi am I here? Pi over 3. So what's pi over 3 short of a full pi? 2/3 pi. So one is 2 pi over 3, and the other one is pi over 3 past a full pi. 4 pi over 3. That is the solution. Holy shit, Jeff. Now you can zoom back out, dude. That is the answer to this in 0 to 2 pi. That's the thing I need to really make it clear. And I think I put it up here, yes. So that's overarching. That's everybody. So that, I need you to understand. If that was my question, if that was the problem I was solving, that's the answer. I'm done. Do you guys see that? So fundamentally, what does this question ask me? What angles makes cosine negative a half? These two angles make cosine negative a half. Okay, let me stop for a minute. Not a full minute. Do you guys see how that pretty much puts together everything, almost everything we've been talking about? And you don't even know yet, but we are going to fold more stuff into this. An equation like tangent theta equals rad 3, which for some reason I put down here again. So number 2 is going to be easy. What angle makes tangent rad 3? Because tangent's big when sine is big. This is big, so it must be pi over 3, because that's where sine is big. What quadrants makes tangent positive? Yeah, 1 and 3. So one answer is just straight up pi over 3. Do you guys see that? One answer is just straight up pi over 3. And the other one is over here with the reference angle of pi over 3. So what angle is that? Yes, cool. Okay, maybe. So number 2 is easy. I think I changed that because I think I had something more complicated than I wanted to do yet here, and I didn't realize, well, we did it already. Shit. So, did anyone try out this problem? Yeah, so the 2 levels of consideration. What angle makes sine rad 3 over 2, just by itself? The number. What makes that number show up for sine? What angles? Or what angle? In the first quadrant, right? What angle makes sine rad 3 over 2? Pi over 3, good. What quadrants should I be in to make sine negative? 3 and 4. So if I make the reference angle pi over 3, now I'm just asking, what is that angle? What is that angle? Yes? So what is this angle? This one's shown up a lot already. 4 pi over 3. And here's a new one. What angle is this one? Wee-ha! Yeah, because you could go back pi over 3 from 2 pi, which is 6 pi over 3, or blah, 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 blah. So you get 5 pi over 3. Is everybody kind of getting the idea? If you break it down into its constituent parts, what things do I need to know to answer this? You can think the number gives me the reference angle, and the sign, positive or negative, tells me what quadrants to put that in. And we've done, everything we just did is stuff we've done before, just not packaged like this. All right, so let's see. Let's try to get a little bit freakier with this. Let's see. Cosine theta equals cosine 2 theta. What is fundamentally different? This is very, very different than the equations we saw on the front side. Yes? Did I restart the freaking... I did. Look at me go. This is fundamentally different. What's the immediate fundamental difference? Say it. Trig equals trig. Right? Some of you guys are like, yes, trig equals trig. Done. Next question. But this one says cosine of theta equals cosine 2 theta. That's like, what the shit? What is cosine equal to itself, but at twice the angle? It's like, what the shit? So in order to solve this, I'm going to have to use a double angle identity. So when I'm trying to verify identities, one of the first things you look for is, does anyone have a different angle? Is everybody theta except this one guy is 2 theta? Is everybody A and B except this one guy is A plus B? And then you kind of focus on that one guy, yes? So cosine 2 theta is an issue here. It's not the same as the first guy. Well, we've got 3 options, don't we? Because again, cosine's an asshole. So I'm going to kind of help you out a little bit, because of course this is one of our first equations like this. I want to choose the option, because that guy is here, I want to choose the option that only has cosines, so that everybody's got cosines. I don't want to introduce sine into this if I don't need to, because then it's not going to jive with everybody else. So which way, and you can use your green sheet or whatever the shit, which double angle formula for cosine only has a cosine in it. I don't want any sines. Can you guys look that up? So don't tell me cosine squared minus sine squared. How can I rewrite this so it only has cosine, but it's talking about theta, not 2 theta? 2 cosine squared theta minus 1. Now everybody is talking about, is everybody talking about the same angle? Yes, and this is not always true, but it's about 90% of the time true. You want the same trig function if you can make that happen, because then they will interact with each other better. Now what we're about to do is very tricky. Very tricky. Let me show you the idea behind what we're about to do. Where have I put all my paper? Oh yeah, it's down here. Can somebody help me out? How would you solve this silly equation here? Yeah. No. If somebody told you, here you go, this is what I got when I solved for x. If somebody said, that's what I got when I solved for x, what would you tell them? I was waiting to see what somebody would say. They need to start over, Jeff. But yeah, you can just say they're crazy. I need all my x's on one side. I need x equals a number, right? So this is bullshit. X, I don't know, equals something else I don't know. Yay! We don't know anything. Are your x's like terms? Can you put this and this together? Can I combine them? Okay. So what do? When you have x's you can't put together, there's x's with different powers on them. You get the whole thing equal to 0. And then you factor. Okay. So I would do this. And I know some of you guys are like, well, this is great, Jeff. What's it got to do with the trig shit we were just doing? I'll show you. Could you factor this? Do you see how the first number is not a 1? But that doesn't trouble me because there's only so many. In fact, it's got to be this, doesn't it? It's got to be. It's got to be that. 2 times 1 is 2. 1 times 1 is 1. Now we just got to figure out the white signs. With the Hunter West squeak at it. So I need to figure out, is everybody kind of with me? When the numbers are really tiny, I can factor easily. I don't have to do the freaking A times C thing or blah, 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 blah. There's only one way to factor 2, and there's only one way to factor 1. Now, where's the signs go? I need the middle term to be negative. So the one I get a 2 from versus the one I get a 1 from. I need this to be minus so that it comes out being negative in the end. That's exactly the way to think about this. And then how would you finish this out? Either x is 1. Can anybody do this in your head? Subtract 1 divided by 2. Okay. So what does this have to do? Dear God, Jeff. It was great. Great, Jeff. Did you have fun? Come back to the problem we actually have. Does anyone see how this problem is this problem? These are the same exact problem. This is something I don't know equals twice that thing squared minus 1. Something I don't know equals twice that thing squared minus 1. Those are the same function. Here's what we do though. What we do for the moment is I just say, let me call cosine theta C. Now that looks exactly like we were just doing, yes? So we do all the same shit. We get to the same place. I already forgot what was that. There you go, Jeff. Good job, buddy. But now I can remember. So what do I get? I get C equals negative 1/2. C equals 1. Is everybody with me? I get the same problem, the same answers we just got, except I'm calling it C so I don't forget its cosine. Yes?
You just omitted the 1.
Oh, thank you. He was shy. He was curved behind the parenthesis. Are you guys at all with me?
Yeah.
This is our first foray, it's one of my favorite words, into functions that are quadratic in form. So this doesn't look quadratic. But if you write cosine theta as just c, holy shit. What was c again? What did we say c was? Cosine. Do you see how that's a problem? And that's a problem. Isn't that a problem? Did we solve it? Yeah, we solved this one, didn't we? Look at the front of the page on here. Kabam! So what did we get for this one? What did we get here? Are you guys with me? This is the question. Yes? So what makes cosine become negative 1/2? Where's it here? What's happening right now? So if I look at what I've got, what equation is right here? Cosine theta equals negative 1/2. Did we already solve this? Yes, cosine theta equals negative 1/2. That would be pi over 3. Get it far away from the x-axis and cosine gets scared. But I know I have to be in the third and fourth quadrants, so that's when we got, I'm sorry, the second and third quadrant. So that's when we got 2 pi over 3 and 4 pi over 3. What makes cosine 1? What angle makes cosine 1? 0. Good. And 2 pi, but do you see how I'm not... Did I put it up here? No, but again, it's the whole damn thing. Because 2 pi is 0, so, okay. So this is our first more complicated question that leads to 2 little equations, and we have to solve each one. So we get 2 answers from this guy, 1 answer from this guy. Any 3 of these makes this equation true. Can you guys check? Can you guys plug a 2 pi over 3 in? Check the equation. Check that this answer works. Plug a 2 pi over 3 in. Check it. What do I mean by that? Well, we got values of theta that are supposed to work. Let's plug them in and see if they work. So I can check any equation I solve in the universe. I can check it. So let me ask the question I know is in somebody's head. Can you say again what you want me to do, but this time in English? Yes. I want you to start here at the beginning, but I'm going to replace theta with an angle that's supposed to work. And what angle is supposed to work? What's one of them? 2 pi over 3. So we get cosine of 2 pi over 3 is supposed to be the same thing as cosine of 4 pi over 3. Yeah, we shouldn't need a calculator. What's the cosine of 2 pi over 3? What's the cosine of 2 pi over 3? What quadrant am I in? Second. Cosine's going to be negative. Pi over 3 makes cosine scared. 4 pi over 3, do you see it's the same dumb thing? It's the same exact triangle, isn't it? And x is still negative, so it's going to be the same value. A pi over 3 makes cosine small, 1/2. Bless you. And that those 2 quadrants makes it negative. So sure enough, it worked. When I plugged that value in, I got values that made the equality true. So it checks that equation. And you can do each value we got, you can plug it in and see if it still works. Okay. You guys doing okay? All right. So try this one. Try number 1. Just give it a try. Just try something. There's an immediate, obvious thing you want to do. And there's another one that should be obvious, but not as obvious. So that was helpful, Jeff. I'm sorry. Try to do the first couple steps. Oh, sure. I'm sorry. I don't need to zoom in. Y'all have this problem. That's a good point. Draw the first couple steps. And I'll tell you this little story. Don't set you all in here. I'll tell you our story. Just today in Calc 2, we were doing this. We were using this to do calculus. The first step was solve this trig equation. So we were doing exactly this kind of stuff in Calc 2. Just so you know, this carries over. Calc 1, you do some of this stuff too. Just so you know. See how far you can get. Yeah, we're not verifying identities, we're solving equations. So we know the equality is true, so we're allowed to do stuff to both sides. What would somebody say is the most obvious thing you should do? Want the same angle. So what's sine of 2 theta? Now, since I got a bunch of sines and cosines running around, what seems to be a smart idea to do with the tangent? Almost. Sine over cosine. That would be cotangent, yeah. Now, I want to stop for a second. Do you guys see, before we go any further, do you guys see a part of this equation that causes certain angles to not work? What part of this equation would freak out if the angle was certain angles, if I input certain angles?
Zero.
Huh?
Angle 0. Cosine would be 0.
Yeah, if cosine was 0, wouldn't this equation freak out? I need you all with me. What would happen if cosine was 0? I would get something divided by 0. That's that's an existential threat. That's a black hole. So let's not let that happen. So over here, I'm just going to remind myself that cosine theta can't be 0. I'm just going to put that right there, just to remind myself. I don't want black holes to show up, so let's keep an eye out for that. Now, what is the worst part of this function besides it exists? Because somebody always says,
The fact that you put it there.
all right, sorry. What's the worst part of any equation? It pretty much is exactly the part we just looked at. The fact that there not only is the trig shit in here, but what is there also? There's a freaking fraction. All right, how do I kill the fraction? Multiply both sides by cosine. So here I get sine theta equals 2 sine theta. What's cosine times cosine? Now, just to cut to the chase here, why can I not divide by sine? I like that. Somebody looked at me like, what I wanted to do, man. What are you talking about? I'm going to do it anyway. Sure. Why? What is the only thing? Go ahead. Sorry. Sorry? No, we don't want to square root anything. That would suck. Thank you. Sorry, I lost that monitor and came back. Nothing to do with me. What's the only number you are not allowed to divide by? You can divide both sides of an equation by anything you want to, except 0. Can sine be 0?
Yeah.
So then you can't divide by it, because it could be 0. Do you know it's not 0? I don't know what theta is, so it could be 0. Hey. Thank you. What's wrong with this guy? So what? I love you guys so much. We're going to be okay. So I'm going to subtract sine. And then what do you think I'm going to do now? Factor. There you go. When you want to divide, you almost always instead subtracting factor. So you don't lose the sign. That's information. Information. So what can come out? Sine. And what's left if I take a sine out?
Sine, so sine squared minus 1.
Huh? No. I didn't subtract a sine out. I divided a sine out. So what's left?
2, so sine squared minus 1.
Yes. So either sine theta equals 0 or 2 cosine squared theta minus 1 equals 0. Let me stop for a minute. You guys with me? That's what we've always done this whole last semester is when I factor equal to 0, I set HV equal to 0. Whoop-de-doo, I don't give a shit if it's trig in there, whatever the hell's in there. Whenever I factor, it's equal to 0, I set HP equal to 0. What is sine equal to 0? What angle? Or what angles? What angles make sine 0? 0? And pi. So if I'm on the x-axis, sine doesn't like it. To solve this, I add 1, divide by 2, take a square root, so it's plus or minus. So what angles make cosine? Let me see if I can cut to the chase. Square root of 1 is 1, divided by square root of 2. If I rationalize, I get something that looks very familiar, yes? What is cosine? What quadrant could I be in? First and fourth and second and third, all of them. Because when is cosine positive or negative? Every freaking where. What are you talking about? So when I have a plus or minus in there, basically all quadrants are open. And what is the reference angle that makes cosine rad 2 over 2? What makes cosine rad 2 over 2? Our favorite little angle, pi over 4. So I want something in the first quadrant, second quadrant, third quadrant, fourth quadrant. There we go. So how many total answers did we get? 1, 2, 3, 4, 5, 6. Crazy shit. That was a lot. I'm sorry. But I need you to see how it's built on stuff we've done. None of this is really new. What's new is the way it's kind of packaged. We've never talked about this like solving trig equations, but we've done this stuff before. We just didn't package it like this. So here's the problem. Here's the main problem. Well, we got one more problem to do. That's the one immediate problem. And then I'll talk about the problem that's left for us to worry about. Any ideas on this thing? Somebody just fell out. Sorry. I don't know why I'm laughing so much, guys. Dumb, but that's okay. Any ideas? What? All right, there is a couple things. If only it was sine squared plus cosine squared. That would have been nice, yeah. But it isn't, because I'm an asshole. Too bad. I'm like cosine. Anybody have any other ideas? Anything. I'm open. Brainstorm. What do you got?
Change like sine squared into cosine squared minus
1 minus cosine squared.
1 minus.
Why is it almost right? Because what's the other thing that's in there? Another sine.
Oh, so you want to change.
So I want to change cosine squared into sine squared.
Yeah.
And what is cosine squared? It's 1 minus sine squared. Yes? So he's kind of like the odd dude out. Huh? Jeff, get the 2 out of there. So if I do this, I'll get sine squared minus 1 plus sine squared. That's the 2 sine squared that Jeff wanted to make show up too early. This should look a little familiar. Doesn't that look a lot like what we had up here? Can't I do it the same way? Except for me, the letter S is bad. So what I normally did was I would make it like a T. T is bad for me too, but it's better than nothing. If your letter S is good, you can make just the same way we did this. Yes, same way we did this. We do it here. So if you can make a letter S not look like a 5, you're golden. Mine look like 5s. So I can just make sign become whatever the shit other letter I want to. Can we factor this? It's just as easy as before, yes? And again, the thing that makes, what am I trying to say? The thing that makes, it's the same stupid thing we had earlier. So the thing that makes 2t, it has to be negative, so that this comes out negative. Equals 0, so then t is negative 1/2, or t is 1. T was what? What was t? Yeah, so I get sine x is negative 1/2. Sine x is 1. Well, what makes sine 1? Pi over 2. And what makes sine negative 1/2? What quadrants would I be in? Third and fourth. Nope. That would be negative 1. I want negative 1/2. So listen, I know it's going to have to be, what makes sine small? Pi over 6. So I know it's going to have to be related to pi over 6, but it's got to be in the third and fourth. So that is 7 pi over 6 and 11 pi over 6. So 1/6 of a pi past pi and 1/6 of a pi short of 2 pi. So I will say there's not much new in what we're doing, but it is kind of a lot at once. It's true, I agree. You got a lot of things to consider as you walk through these problems. But the main idea of almost all mathematics is the more you can break it down for yourself, the easier each part is. Okay. So I want to say one word about, well, maybe more than one word. One quick thing about the next level of this. Because here's the thing. If I ask you without any constraints, when is sine theta equal to 1? No constraints. When is sine theta equal to 1? Why is that not the only answer? Because are there coterminal angles with pi over 2 that would make sine 1? What's the coterminal angle with pi over 2? How do I find a coterminal angle? I just add how much to it to get back to where I was? 2 pi. So what's pi over 2 plus 2 pi? We'll make 2 pi equal to 4 pi over 2, yes? So what do I get when I add 4 pi over 2? Add 4 pi over 2. What am I doing? What's 4 pi over 2 represent? Me starting at an answer and rotating all the way around. And of course, where I end up is another freaking answer, isn't it? So this would be 5 pi over 2. Keep going. Keep going. 9 pi over 2. How long would I have to go? And here's the great thing. It's not just one infinity. It's 2 infinities. Because I could also go back. Sorry. At the moment, it's impossible for me to laugh any other way than evilly. All right, sorry. No, that was more of a play. Who cares? So if I start, here's how I write this really quickly, because I don't have time to write all the answers. Here's what we do. You ready? This is kind of dumb. I go forward, not just 2 pi, but any multiple of 2 pi. And books differ. I always forget to look at our book, but the one I normally use is K. But some books, sure, Jeff. Some books use N, 2 pi N. But all that letter means is K is 1. That would be 1 rotation. 2, that's 2 rotations. 3, that's 3 rotations. And in general, K could be negative, but just to really make it really clear, I can go forward multiples of 2 pi or backward multiples of 2 pi. So that captures the infinite answers. Now those answers are dumb because they're all this, yes? Every single answer
Is this? It's just, did I rotate once, or did I rotate backwards 11
it
times?
doesn't matter. You end up at the same place, yes? So we're going to see, when I say find all answers, you are going to put, very often, but not always, plus or minus 2 pi k. What is 2 pi related to sine? 2 pi is the what of sine? What aspect of sine is 2 pi? Is it the amplitude of sine? Is it the phase shift of sine? What is 2 pi? It is the period of sine. What's the period of tangent, for example? So if I have a tangent equation, I bet you most of the time it's going to be plus or minus pi k. Because that's how often it repeats itself, yes? There are other things that are going to make it change, and we'll talk about those tomorrow. I think this is enough for right now. So tomorrow, we'll finish up trig equations. We'll talk a little bit about section 2.6. And I'll have the practice final for you tomorrow.
I get a copy of the
Of who?